Hi, I hope everyone's having a great break. We're going to talk about the nomenclature of carbonyl compounds, specifically aldehydes, ketones, carboxylic acids, and esters. Okay, remember that ketones have alkyl groups on both sides of the carbonyl, and aldehydes have a hydrogen on one side of the carbonyl. You can have hydrogens on both sides of the carbonyl. If you do, that is formaldehyde. And that's the only one that can be that way. Okay, so for aldehydes, you're going to drop the E at the end of the basic name and add Al. Al for aldehyde. It is important that when you write these things down, that you write them so that I can tell the difference between an Al and an Ol. Okay, so just keep that in mind when you do your tests. The carbonyl carbon of an aldehyde is always carbon number 1. Notice that it has to be at the end of a chain. You can't have a carbonyl carbon in the middle of the chain and have it be an aldehyde. If it's in the middle, then it is a ketone. For common names, we're going to use the ending aldehyde. And I just want you to understand about the common names because you'll run into that. That's how people talk. That's how sometimes bottles are labeled, stuff like that. Okay, so if you have just the carbonyl, 1 carbon and 2 hydrogens, that has 1 carbon, so that would be methane, so it's methanal. Okay, the common name for that is formaldehyde. And to be perfectly honest, I've never heard anyone call it methanal. Everyone has called it formaldehyde. Same thing with ethanal. Ethanal is more commonly referred to as acetaldehyde. Okay, now look at this compound. This compound has 3 carbons, so its base name is going to be propanal. And notice that the bromine is on carbon number 2. So it's 2-bromopropanal. There is a common name system that's used that uses the Greek letters, alpha, beta, gamma, delta. That's how close they are to the carbonyl. So if you look at that bromine, it is actually on what we call the alpha carbon. It is next to the carbonyl, directly next to the carbonyl. Okay, so what would be the name of this one? Well, your longest chain of connected carbon atoms is 4. Remember, the carbonyl carbon has to be in that chain. So that's going to give you butanal, and then you have a methyl on carbon number 3. So it's 3-methyl-butanal. Okay? Remember that compound names have 3 parts. You have the root for the number of carbons in your base chain. Then you have that center part that's going to be AN, EN, or YN, depending on whether you're all single bonds between the carbons, a double bond, or a triple bond. And of course, you can have it mixed up. Like you could have a double and a triple. Okay? The ending for the functional group is going to replace the E. Okay, so if it was just an alkene or an alkyne, then you would just end with the E. But because it's an aldehyde, we drop the E and add Al. Now, what if you had 2 aldehydes? Well, notice that they have to be at the ends of your chain. One will have to be on the left and one will have to be on the right. So that will be hexane dial. Notice it's dial, kind of like the soap, D-I-A-L. But they put the di in there for the 2 aldehydes. And notice that E is in there. That's so that it's hexane dial and not hexane dial. I don't know. I think it's an English thing, to be perfectly honest. Okay? Notice they still don't put any numbers. Now, could you have a trialdehyde? You cannot, because your chain only has 2 ends, a beginning and an end. So you're either going to be hexanal or you're going to be hexane dial. Okay, you can't be hexane trial. That's impossible. All right, so here's some more examples. So look at this compound. So what is the longest chain? It's 4. Remember that the carbonyl carbon counts when you're figuring out the longest chain. Okay, so that's going to be butanal. And then you have a bromine on carbon number 4. So it's 4-bromobutanal. All right, now here's one with one of those lovely double bonds in it. Okay, so the longest number of carbons is 7. Okay, so you've got hept for that, and then you're going to have En because you have an alkene in there, and then you're going to end with Al for the aldehyde. So that's going to be 5-heptenal. Okay, does everybody see how we got that far? Remember, the 5 is the number of the first carbon of the double bond. Okay, now I want you to notice that it's not just 5-heptenal, it's trans 5-heptenal. Okay, so make sure you pay attention to that with double bonds. Triple bonds do not have cis and trans because they're linear. Okay, the other way that you can write this is with trans hept 5-enal. Okay, once again, we don't put the number 1 for the aldehyde because it has to be number 1. Okay, you can't have hept 5-ene-2-al, then it's not an aldehyde. All right, what about this compound? Holy moly. Okay, so look at this. Do you see that? That right there is benzaldehyde. So that is going to be your base name. That is the special name for that benzene derivative, benzaldehyde. And then you're going to number it so that you get the lowest possible number. The benzaldehyde carbon, the carbon that's attached to the carbonyl, is going to be number 1. So the ethyl group up there has to be number 2. Okay? And then, of course, you have your T-butyl at 5. Okay, so it's going to be 5-T-butyl, 2-ethyl benzaldehyde. Remember that when you alphabetize, tert-butyl gets alphabetized by the B. I did not make any of those rules. Don't be mad at me. Okay, what about this? Okay, I'm showing you this one because I want to remind you that the CHO stands for an aldehyde. Okay, and notice that not only do we have an aldehyde, but we have an alcohol in there. Okay, so what happens when you have more than one functional group and there are potentially different endings for your molecule? Well, what happens is we have, well, I say we, but I really had nothing to do with it. But what happens is a priority arrangement has been decided. And actually, the aldehyde beats the alcohol. Okay, so that gives us the name of 5-hydroxyhexanal. So notice that the OH is referred to as a hydroxy. No L, not hydroxyl. It's just hydroxy. Okay, and the carbonyl carbon of the aldehyde is still carbon number 1. Okie dokie. We'll have a little more on that in a minute. Okay, nomenclature of ketones. Okay, to name a ketone, your ending is going to be -one. You're going to give the carbonyl carbon the lowest possible number. And there are common names where you name the groups on either side of the carbonyl and add ketone, and it's 3 words. I'll show you a couple of those just so you see that. Okay, this is propanone, more commonly referred to as acetone. It has also been called dimethyl ketone. So we don't say methyl ketone. I mean, I guess you could, but nobody does. In fact, everybody calls it acetone. All right, look at this one. This one, it's a ketone. You have R groups on both sides of the carbonyl. You have an ethyl on one side and a propyl on the other. So your compound is going to be 3-hexanone. That's how many carbons are totally in that chain. Remember that the carbonyl carbon has to be in the chain. So your common name is going to be ethyl propyl ketone. Ethyl propyl ketone. Okay, look at this one. Okay, so what is the name of that? Well, you've got 1, 2, 3, 4, 5, 6, 7 carbons in your chain. You have a methyl on carbon 6, and your ketone is on carbon 2. So it's going to be 6-methyl-2-heptanone. 6-methyl-2-heptanone. The special common name is isohexyl methyl ketone. That just rolls off the tongue, that isohexyl methyl ketone. Yeah, that's why we don't always use those common names. All right, here's a few more examples. So what do you think the name of that is going to be? I'm pausing to give you time to think. Okay, it's going to be cyclopentanone. You see how we got that? So you have pent for 5 carbons in your ring, AN because there is all single bonds between those carbons, and ONE because it's a ketone. And in the whole front, we put cyclo because it's a ring. Okay? Now, if there was something on that ring, like a bromine, okay, what carbon do you think is carbon number 1? The carbon of the carbonyl. So because of that, we do not put the number when there's only one carbonyl. Okay, what do you think about this one? Okay, your chain is going to be how many carbons? 6. That's going to give us hexyne 3-one. Okay, you want to give the carbonyl the lowest possible number. Then the triple bond is just going to get whatever number it ends up with. But the carbonyl carbon gets the lowest number. So we don't number from the right because that would make it 4. Okay, is everybody following? Notice that it's hex for the 6 carbons, YN for the triple bond, and -3-one for where the ketone is. And of course, you have a 1 at the front for the triple bond. Okie dokie. All right, what do you think about this one? This one has a ketone and an aldehyde. Okay, so remember I said that there are priorities for the functional groups. Well, guess who wins, a ketone or an aldehyde? Aldehyde wins. Okay, and what happens to the ketone? How do we name it? We name it as an oxo group. So notice that we have 4-methyl 7-oxo-octanol. Okay, 7-oxo-octanol. No hyphen in there. All right, have you seen this compound? This compound is referred to as acetophenone. It's one of those special benzene names, okay, for the aromatic compounds. Now let's stick something on there. How about a nitro? Okay, so what is the name of that going to be? Para-nitroacetophenone. See how we got that? Para-nitroacetophenone. You could also say 4-nitroacetophenone. The carbon that the carbonyl methyl, that acetyl group is attached to, is automatically carbon number 1 because it's the base name, acetophenone. Okay, and back to regular acetophenone. I want you to notice that the common name would be methyl phenyl ketone. Okay, so the functional groups have been assigned relative priorities. The highest priority functional group is going to get the base name. They're the big winner. The other functional groups are treated as substituents. And remember that alkenes and alkynes are designated in the center of those base names. So like, what would the name of this be? Well, your longest chain is 4. It's an aldehyde, okay? So it's going to be 3-hydroxybutanol. What about this compound? 5-oxohexanol. Okay, is it sinking in? The 5-oxo is for that ketone. Okay, the aldehyde wins. Aldehyde wins. So here is a summary of the functional group nomenclature. And it includes some that we're not even going to worry about, but when you go up the table, okay, the top of the table is increasing priority. So the big winner in organic nomenclature is the carboxylic acid. Okay, ester, amide, nitrile, aldehydes, ketone, alcohol, amine, and then you get alkene, alkyne, alkane, and poor little ethers and alkohalides. They don't even really count. All right, so look up here at the aldehydes. You notice there's 2 of them. What do you think that formyl is? That formyl is a group that is on something else, like a ring. Okay, so it would be something like that. Oxo is its name if it was in a carboxylic acid. Okay, so this table ought to help you like kind of just get it straight. This is what the right column is what you call the groups when they are not the winning functional group. Okay, so here is a carboxylic acid. Top of the pile there. Replace the terminal E of the alkane name with oic acid. So there we have what? Methanoic acid, more commonly referred to as formic acid. Here we have, what's that one going to be? Ethanoic acid. Notice that the ic acids, the acid is a second word. It's not part of the first word. So if you have to type that into something, make sure you put a space in there. Okay, what is ethanoic acid, more commonly referred to as acetic acid? All right, how about this one? Butanoic acid. Its common name is butyric acid, and it stinks to high heaven. It smells like rotten butter. Bad, bad stuff. Okay, here's another stinky one. This one is hexanoic acid, otherwise called caproic acid. Some of these carboxylic acids stink like goats, like dirty goats and sweaty feet, and ugh, they're nasty stuff. All right, look at this one. We got a little double bond action in there. Okay, how many carbons? 3, so that's prop. En for the double bond, and oic acid, so it's propenoic acid. We're not putting a number for the double bond because there's only 3 carbons. There is only one spot where that double bond could go. Okay, now this is commonly referred to as acrylic acid. Guess what acrylic acid is used to make? You got it, acrylic. Okay, here is our hexanoic acid. Okay, and I numbered the carbons 1, 2, 3, 4, 5, 6. Okay, and then over here on the right, I have alpha, beta, gamma, delta, epsilon. Okay, the common carboxylic acids will often use those alpha, beta, gamma, delta, epsilon terms. Okay, these are the common carboxylic acid names that get used: formic, acetic, propionic, butyric, valeric, and caproic. Okay, that's 1, 2, 3, 4, 5, and 6 carbons. Okay, so this one, the hexanoic acid, is referred to as caproic acid. All right, if you put something on the chain, so for example, this compound has a methoxy group on it, and it's on carbon number 2. So the IUPAC name would be 2-methoxy-butanoic acid. What would the common name be? Well, the methoxy is on the alpha carbon, so it's going to be alpha-methoxy-butyric acid. Okay, sometimes you'll see this. I think they like to use it in biochemistry some. That's where I've seen it, and just in general. Okay, so what do you think the IUPAC name first for this one is? 1, 2, 3, 4, 5. 5 carbons is pentanoic acid. Okay, and then we have our bromine on carbon number 3. So it's going to be 3-bromo-pentanoic acid. Okay, what would be not the IUPAC, I'm sorry, the common name? So you look at where that bromine is, it's on the beta carbon. You go alpha, beta, okay? And pentanoic acid has valeric is its common name. So it's going to be beta bromo valeric acid, and it's not coming. What's going on? Something happened. My laptop is like not working. Hang on. I don't want to start over. There it was, right there in the bottom. Beta, Valero, okay. Okay. All right, so let me put my share back up. I don't know what y'all are going to get out of this thing. This is nutty. Okay. All right, I'll put my share back up. Make sure that it's, oh, I guess it's back. I could have paused the recording. I didn't know that. All right, so let's try it again here. Do you see on the bottom it says beta bromo valeric acid? Okay. Oh my gosh. All right, we got to show everything again. Hang in there. Hopefully we'll get there. This isn't very long. All right. And here should be my beta bromo valeric acid. Woohoo! All right, here's the esters. Remember that an ester has that carbonyl O in the middle, but it has carbon hydrogen groups on both sides. So the first thing you're going to do is name the group directly attached to the oxygen first. In our little schematic up here, it's the R prime. It is a separate word ending with YL, a separate word. Then you name the rest like it's a carboxylic acid. You drop ic acid and add 8. Okay, notice we're not adding ester. We're not adding the word ester, okay? All I can tell you is esters are used for flavors. You ate the esters. That's the only way I can tell you to remember it. All right, so you look at this compound. Okay, over here on the right, attached to the O is an ethyl group. So you're going to write ethyl. Okay, so just write down ethyl. Okay, and then the rest of this over here on the left is from acetic acid. So it's going to be called ethyl acetate. Acetic acid and formic acid are just totally accepted. All right, so look at this one now. What is directly attached to the O? A benzene ring. That's called not a benzene, a phenyl. Okay, and then the carboxylic acid over here would be propanoic acid. So it's going to be phenyl propanoate. I'm not quite sure if my laptop is having problems. Okay, here we go again. It gets and then it just fine, and then it quits on me. Okay, there's the phenyl propanoate. Notice we dropped ic acid and add 8. Okay, so look at this one. What's attached to the O is a methyl. And then you have 1, 2, 3, 4. So it's going to be methyl 3-bromobutanoate. Notice that the 3-bromo is with the butanoate part. Okay, that methyl is separated, okay, with a space. Okay, now you get a little practice. Give the IUPAC name for the compound below. Tick, 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 tick. Yay, it's D. Trans 4-chloro-2-hexenal. Okay, so it's trans, the double bond, and it starts on carbon 2, Okay, so that's where the 2-hexenal is from. 1, 2, 3, 4, 5, 6. And the chlorine is on carbon 4. Okay, here's one more practice for you. Aim the compound below. So who's the big winner here? Carboxylic acid is. Yes, the carboxylic acid is. Okay, so that's going to be number 1. So we're going to go 1, 2, 3, 4, 5, 6 methyl, 7 oxo. So it's this one. Okay, I hope you enjoyed that. I hope it comes out. I hope it's not too bad since the thing, I know, my laptop only has to make it 3 more weeks. We're all praying it does. All right, y'all take care. Have a good holiday.